Hello and welcome to the January 3rd edition of the Cluster API breakout meeting for SIG Cluster Lifecycle. It's the first meeting of the new year. Looks like we have an agenda item from Charles Crouch at the top of the meeting here. Charles, are you around to talk to that, or do you want me to read it for you?
No, I'm here.
Excellent.
If folks can hear me?
Yes, thanks.
Great. So very briefly, I was just wondering if people had more input on how that pull request that I linked impacted how people trying to implement the cluster API should go about doing that. Because basically it moved a lot. It moved all of the GCP specific code into a new folder on the kube deploy, along with the stuff that could normally have been considered common across implementations using the cluster API, I think. So if somebody was more knowledgeable could perhaps describe how you would go about doing an implementation now. Awesome.
Sure. Yeah, so this is something we talked about right before the holidays, and I wasn't sure if it had been done, but it looks like Jessica snuck that in before now. So the point of the refactoring here was that the cluster API directory should have only cloud agnostic reusable code. So that includes the API definition, which is still there. It includes tools we build on top of that API definition that don't have any specific ties that are vendor specific. And it includes reusable libraries. And so I think what we did ripping out the GCP code was take everything out that was GCP specific and a lot of the dependencies with the intent of moving the common code back into the shared directory as we found out that it was common. We didn't want to leave a bunch of stuff in there that might be common code because the fewer places that code is used, easier it is to maintain, and you only want to promote it to be like truly shared code if it is actually being shared. And so I think the plan is at the top level where we now have the cluster API-GCP directory, we'd create new directories for each a machine controller implementation effectively. So you'd have AWS or Rackspace or VMware or wherever else we want to support. And as we start building those, when we find common code, we promote the common code back to the cluster API directory. What we want to achieve with the cluster API directory is something that's really easy to vendor, and the fewer dependencies it has, and in particular, we don't want it to include like client libraries for Google or Amazon or anybody else, because those are pretty large dependencies. So in effect, since we're in the same GitHub repository, we don't have to vendor to the other directory. But we want to make it really easy to vendor so that you could create your machine controller outside of the kube deploy directory, but very easily reuse both the API definitions and any reusable code that gets promoted back into the cluster API directory. Does that sort of answer your question? The intent was not to like isolate that code and not make it reusable. I think it was just easier to pull out everything for now because we don't have that sort of second implementation in kube deploy yet where we can see really easily which parts of the code should be reused.
Right. Yes. I think that it may make the job of writing that second implementation a little bit harder because you have to write your own implementation that's cloud specific, and then you also have to pull out from the GCP implementation bits that you want to reuse. But that's just my not particularly well-informed opinion, right?
Yes, that certainly sounds like it could be true.
My only other comment was, would there be an expectation that that sort of change, the description that you just gave there, would appear in the PR?
That probably would have been useful. I think we're sort of hopefully now at the tail end of our sort of rapid iteration that we were trying to do sort of as part of the last quarter's development push to get something that was actually functional and demoable. And now that we have a broader group of people that are interested in sort of following along and helping make this project go and building more implementations, I think we need to switch from our development cycle of write code, self-commit to just make sure we're moving really fast, to hooking up to sort of the common Kubernetes sort of tooling, where we can get the merge bot and the LGTM bot hooked up for our repo. So I think that's definitely should be a next step where we're actually getting code reviews, right? Because in this case, this PR had no description. Jessica and I had talked about it in person and sort of had the conversation that I just told you. But she didn't translate any of that into the PR description. Probably because she assumed we've already talked about this. We know what's going on. But it does make sense to make it clear as we're sort of communicating with a larger group. I think if that had gone through code review, that question would have come up as we should put something akin to a release note-ish thing here, or a description of why we're doing it.
Got it. Great. Thank you very much.
I can also go back and fill that in so that for the future people know what that PR is about.
Yeah, I think that would actually be really useful too, because then they don't have to try to find this recording and hear me ramble about it. All right.
I just wanted to say that I did a Spike implementation, and what I did was I copied and pasted the cluster API GCP code into my code, so that then I would have a static version, no worries if it changes upstream, and then I can see I'm still close to the upstream, and then I can see what fits and what doesn't. So it's sort of controlled, but has a nice path for upstreaming or suggesting changes back up.
Yeah, and since you've done that and sort of been experimenting with it, that probably helps you identify here are the large chunks that are common, right, and don't have any cloud-specific dependencies, things like watches against the API and so forth, that would be really obvious candidates to pull out into common code, that would help make that next implementation easier to do, that Charles was concerned about, right? Since you've sort of already done a lot of the legwork there.
Are there, I'll stop after this question. Are there any areas that people feel are sort of potential candidates for moving out of API GCP back into cluster API? I listed a few, I'll make them bold, in the notes, like the machine controller. Is that something there's reasonable people could decide would be a common component?
There's another area like common implementation. For example, in current machine controller implementation, we use remote SSH as a way to doing handle upgrade, patch the node. So this kind of functionality, I think, could be applied to all the cloud provider, right? To the remote SSH management, to has implementation mechanism to handle upgrade. So it could be common across all the cloud providers.
So Fang, it was unclear to me whether you were saying you were agreeing or disagreeing with the suggestion that the machine controller, large parts of it could be moved into common code.
What I'm saying is that inside the machine controller is a bunch of code could be common across all the cloud providers.
Wait until somebody else has a bigger fuck up. To fix our fuck up. So let's just recommend that we.
So I guess the.
Go ahead. Sorry, there's some background noise. I'm trying to figure out who to mute.
So I think my final comment on this, I guess, would be that you would expect as part of a second implementation that there would be PRs along to move the pieces that implementer thinks are relevant back into cluster API, and we can decide whether we agree on that in the PR process.
Yes, that's sort of what I was envisioning, because I think that trying to do that a priori is likely to lead to too many things actually being stuck in the reusable parts that aren't actually being reused.
Sure.
Although we can sort of take a stab and say, like, these are things that are really obvious that would be reused. Let's sort of promote those now, and we could try to go back and audit later and say where are the dependencies for this code, and if there's really only dependencies in the GCP directory, we can pull them back out again. So yeah, I would be fine with a PR that was sort of made a speculative, like, we think these will be reused even if we don't have a concrete implementation somewhere else yet. And then as we build those other concrete implementations and we find out if they're not, we can pull them back out.
Okay, great. Thank you.
We started also on the first alpha implementation of the machine controller. I can also later paste the link. We did an implementation, what we have now, DigitalOcean and AWS. Yeah. And yeah, the PR for node set or machine set is on the way, more or less.
So it would be worth, Sebastian, probably coordinating a little bit with Justin, because I think Justin's Spike implementation was also on AWS as part of COPS. And I presume that there's some common code there talking to AWS APIs.
Yeah, I mean, our main focus is only spinning up worker nodes, but definitely we will catch up with Justin.
I actually started with bare metal, just for your information.
Oh, very cool.
Not what I was expecting. All right. Do people have other agenda items that they want to talk about?
If we have time, I would be curious to hear discussion around I believe it was a follow-up from last week, or the last meeting, which I was unable to attend, but Chris Rousey filed an issue around the subject of scoping for the resources, whether they be global to the cluster or namespaced, and put forward 3 options. Actually, I'll just find the link here and post it in chat. There it is. Okay, yeah. I was curious if anyone had thoughts on this yet.
All right, I'm just taking a look through that to jog my memory, since it's been a little while since we wrote it.
We had a chat within our team and also arrived at the 3rd option sounding sort of preferable for our use as well.
You say you arrived at the 3rd one. It looks like the 3rd one has sort of sub options for which sort of special codified namespace the whole cluster would be in. Did you guys have a preference among those options?
Not particularly, no. To my mind, local cluster sounded like a nice reference to localhost, but local or kube system, something like that would be fine.
Can you expand a little bit on what use cases you have for representing machines that aren't part of a local cluster in the same API server as machines that do represent the local cluster?
Let me think here. I don't know as that would be the case that they would be combined, but the code base that we're working on could be used potentially in both cases. Our primary goal was a cluster that was managing other clusters. But we've seen some paths to use cases where a cluster managing itself may be useful for us as well. So the code that we were working on potentially could support both. I don't know as it would be together. can't actually think of a situation where they would both be together for us.
Okay. So the cluster that's managing, I mean, at some point there's going to be a turtle at the bottom, right? So there's going to have to be some definition of the root cluster that is managing the other clusters also?
Yeah, well, that's a good question. I mean, our root cluster, we haven't really discussed how that would be itself managed. I was thinking it's probably be one of our pre-existing systems, but pre-existing systems for installing and upgrading.
Okay.
That's something we need to think about, though, actually.
Sebastian, is that along the same lines of with what you guys might do at Lutzy? Because I know you guys are really interested in sort of nodes and managing nodes. Do you think it would be more useful to store the definition of those nodes in sort of the customer cluster itself, where they're sort of local to that cluster, or would it make more sense to store them in a sort of a management cluster, if you will, along with your control plane that's hidden?
That's actually a very good point. I so far only had a very short discussion about it. We want to give our customers the opportunity to customize a bit. So we currently store the nodes or the machines in the custom clusters. But yeah, this is actually very cool and a nice idea to just start in a root kind of cluster. Yeah, definitely. I think it would be interesting to have both options. I think the use case for us would be also quite often that we have it in the user or customer cluster, because they want to scale the node set, for example, so they need access to it. But for example, probably the controller itself will live outside of this cluster, so he only will look inside the cluster and talking to the API server. That could be also one use case, that the resource itself are living inside the cluster, but the controller lives on a different cluster.
Oh, interesting. Okay.
Yeah, that's kind of how I imagine it working also, is in a lot of cases, the controller can live outside the cluster. So this is one of sort of the key differences between the cluster API and other Kubernetes resources that Chris and I tried to present in our talk at KubeCon, is for pretty much all other Kubernetes resources, they are local to that cluster by definition, and the controller for those resources is inside the cluster. But for the machines themselves, I think there's a really good argument for having the controller be outside the cluster for reliability, where you can talk to your cluster endpoint and see how your cluster is described, but the thing that actually reconciles that isn't inside the cluster, because if your machines aren't actually working, you still want the reconciler to be able to fix them and bring them back so that they continue to work. So it sounds like, Devin, in your use case, the people actually that have clusters either wouldn't be able to, or maybe aren't interested in listing like the set of machines or adding or removing machines from their cluster, or they would maybe have a different API for doing that?
Yeah, what we had envisioned was that they would be using some kind of external front-end web application to control all of that. We have not discussed having the controllers outside and having the objects in, which, and actually I'll bring that to the team because I'm curious what they think.
Okay. Yeah, because I guess I could imagine that external UI, it'd be pretty easy to just have it call the cluster API directly instead of sort of do a roundabout mechanism, and then users could use other existing sort of cluster API specific client tooling on their cluster directly as well, right? So if we have a generic tool that does node repair, for instance, and you guys expose the cluster API to your users could easily attach a node repair tooling onto that cluster, and it would just work. Whereas if you hide the cluster API from them and put it in your own cluster that they don't have access to, and force them to go through your UI, then that might make it harder for them to reuse some of the generic tooling that we expect to build around the cluster API.
Okay, this is great. Thank you.
I haven't read the initial implementation that's written up in the Kubernetes book. Could somebody explain how the source and target work for the controller? So just to clarify, where the source objects come from and how the controller remediates those in a target cluster. Because that kind of seems like where the question would be. If the source and target on the controller are configurable, then it would allow you to feasibly even run like two controllers, in both the cluster and then one external to the cluster that could remediate the same state target.
I'm not sure I can answer that question. Feng, do you have a good answer to that question?
What's the next question again?
The question is about how the current controller implementations deal with source and target mappings, I guess. So where the source of the API objects is coming from, and then what the target cluster is kind of where those objects are supposed to be realized. And because there's been, I think, like pretty consistent discussion over the past couple of meetings about like whether or not a controller should live in or out of the cluster, and whether the storage of those objects should be in or out of the cluster.
I don't quite understand the question. Do you mean the versioning of the source and the target?
Kind of thinking about the, yeah, I don't know. Maybe it's getting a little strange. I'll have to think about the bootstrap a little bit. I'm not sure if my question makes sense now.
Maybe we can follow up offline.
Yeah.
Just building off the bootstrap comment, do we, if we're dealing with a situation where your API objects live in the cluster, your controllers live outside, how does that flow in a situation where the cluster doesn't yet exist and you're looking to create one?
I see. Current implementation always like basically bootstrap whatever the version specified manifest, right? So because the current implementation always have like a controller that living inside the cluster. So if the controller living outside the cluster, I think I need to give it some thought. So.
Yeah, so I think there are a couple options. If your controller is outside the cluster, you can give the controller that definition of desired state, and then it can vivify the cluster and stick the desired state into the cluster as sort of the record of that desired state going forward. Obviously, you have an issue there if that controller process loses that information as it's running, so it'll probably need to checkpoint it somewhere else in the meantime. You can also do something like what COPS does, which is have client-side tooling, where you basically run the controller client-side while you vivify the cluster, and then pivot sort of the control of those objects inside of the cluster or to that external controller after the cluster's up and running. So I was sort of imagining something like the latter would be common, where you'd run a command on your machine that says, create my cluster. And this is what the current code in kubedeploy does, is it basically, well, it's actually even simpler than that. It creates a master machine, installs a CRD, and then runs a machine controller there. But I think as we expand our use cases to things like multiple masters, we'll probably run some version of that machine controller locally to sort of reconcile that initial state and then pivot the machine controller into the cluster afterwards.
Okay, thank you.
And that would work just as well if that machine controller is run, locally on your laptop, or if it's run like on a server, as a hosted service. You can just run it outside the cluster to sort of vivify the state. And then if you want, you can pivot it inside the cluster, or you could, if it's, as a service, you could keep it outside the cluster for the lifetime of the cluster to keep it running. Obviously, if you're in it, vivifying the cluster from your laptop, keeping that controller outside the cluster on your laptop is probably a bad idea, because your laptop's going to go to sleep or be turned off. And in that case, you probably want to pivot it into the cluster, or into some sort of, root cluster off to the side, like you were talking about, that's managing the cluster for you.
Okay.
So with something like kubeADM, where the pod pivot is kind of determined by the availability of the network socket, we don't really have that privilege if the vivification is happening from like a different machine. So would we want to put like a lock somewhere in the cluster API? No.
For which use
The
case?
problem being that if you were to install a controller in the cluster at the same time as when your external controller is living, there might be a race. Really.
Yeah, I think in general, we need to make it safe to be running multiple controllers, right? In the same way that you can run multiple schedulers, like not multiple schedulers instead of two different schedulers, but the same scheduler binary twice in one cluster, the same controller manager binary twice in one cluster, and only one of them is active. The machine controller is going to have to be smart enough to do the same thing, because the easiest way, like you should just be able to run 3 of them in your cluster and have them fail over also, right?
Yeah, so you're getting at just a per resource lock, then maybe similar to how the scheduler works.
I mean, I think the scheduler and controller manager are both more coarse than that. I think it's just like a lock basically for the binary. Like there's one scheduler binary that is in charge. It's not for each scheduling decision they race to take a lock. It's one of them is in charge and the other is sort of a hot standby, and is sort of watching all the things come by and not taking any action. And then if the primary one disappears, one of the standby ones will race to grab the lock, and then it will start taking action instead of just observing. And so that's sort of the simplest way to do it, is to have this sort of coarse global one takes action, the others don't. And you could then break it down and have more fine-grained locking if you wanted to shard better.
So we haven't done that, but the answer is probably yes.
Yeah, I think we need to do that, because I think it needs to be safe to run multiple instances of the controller. If for no other reason than if we're scheduling the controller into the cluster, there's no guarantee that more than one won't run at a time, right? Unless we're using something like stateful sets, which does have a strong guarantee that more than one won't run at a time. And I don't think stateful sets is the right Kubernetes object to describe the machine controller. Right.
This is a PSA. The helps write that code. It by default locks on an endpoint, but you can configure it to lock on config map. So you can modify that over time, because the endpoint modifications hopefully be deprecated, because endpoints have scalability issues.
That's the scheduler you're talking about, Tim?
Scheduler and controller manager, like Mike, Denise, and I worked on the locking code.
Is that a shared library?
It is, and it's reusable, so folks can just leverage it if they have external components. And I think it even got migrated to the client library, so folks can just leverage it for external components that they create.
Cool. And that means also that if we fix it to not use endpoints and to use something better in the future, that fix will also propagate to people that are linking in the library too, right?
Yes, it's already defaulted, or it has the ability to be configurable to use config maps, and that's in the library. That was a requirement that people asked for, to be in the client Go library for usage.
Awesome. Sounds like we should just use that then and not reinvent how do we grab a lock. All right, well, I'm adding that to the notes. Are there other questions, topics people wanted to talk about? If not, I have a thing or two I can bring up. All right, so the first thing I want to talk about was how we engage new contributors. So I've had a couple of different people say that they're excited and they want to contribute to either documentation or code, but aren't sure where to start. And so I think one thing that we need to start doing is generating a backlog and a set of sort of needs work or new contributor labeled issues in the kubedeploy repository. And so I think there have been a couple things brought up at this meeting that would be perfect for that. So what Charles was talking about lifting what we think is reusable code and sticking that into the cluster API directory. I think that's something that would be pretty easy for someone new to look at and say, here's some code, it doesn't have any external dependencies, let's make a PR to move that over. I think that the thing that Tim just mentioned about adding locking code would be relatively straightforward for someone who's experienced in Kubernetes, but sort of maybe wants to start contributing to this project to bring that forward. And I think that there's probably another set of things, adding sort of the common Kubernetes sort of infrastructure into our project with various bots we can configure, and the submit queue and those sorts of things are all sort of pretty good starter projects, I would say, for people. Or does anybody else have other things that they think would be good, sort of easy on-ramp projects? Okay, I will try to keep thinking of them and start tagging those. And if people are looking for, I guess documentation is the other sort of obvious one in terms of cleaning that up. If people are looking for small things to get started, I think that hopefully maybe by the end of this week we'll have a list of issues that we can point people to via a label query to find sort of small things to bite off and start contributing.
So along with the list of things to do, is there the widespread expectation that core reviewers will review the PRs that are either currently up or will be up based on this list?
Yes, so one thing that's going to need to go on the list is setting up like an owner's directory and making sure we put people in there that will review PRs. I'm trying to think. I don't think. I think. Justin, do you know who has access to Cube Deploy?
I think Chris and other folks. Let me check right now.
Yeah, so we don't have any sort of code level owners files like we've started to put into the main Kubernetes repo. We should definitely do that. And that way we don't have to give everybody write access to the entire Git project. If we have owners files and some of the common product automation set up, people should be able to use the bot to merge code. So like I was saying, I think that's one of the next things we want to get set up because that will help us be able to scale contributions. And then sort of as with other owners files, we need to make sure that people in those files are actively reviewing PRs that come by. For now, if you send PRs, feel free to ping me on them and I will either look at them or make sure someone does. And so I guess the other thing we can talk about is roadmap for 2018. So I know that, I don't know if everybody's seen it, but Lucas from SIG Cluster Lifecycle put together sort of a broader roadmap for the entire SIG, which has a section for kubeadmin, a section for cluster API, a section for component config, COPS, add-ons API, kubespray, sort of all of the different projects that are going on underneath the umbrella of the SIG. So if I read through the section about the cluster API, let me link that doc in chat real quick if people haven't seen a link to it. For the cluster API, the straw man that he wrote down, which we should probably validate as part of this sort of sub-working group, is in 2018, we'd like to basically at least have a beta version of the cluster API. So that is broken into the control plane API section and the machines API section. 2018 is going to be a long year. Hopefully we can get a final sort of V1 version of the API before the end of the year. I think we have a very good chance, if not 100%, of having a beta version, because I think the bar for beta is not too hard for us to reach. And ideally, we'd get past that. And on the implementation side, having machine controllers for various environments He wrote down GCE, Terraform, maybe Docker. People have obviously mentioned AWS, vSphere, DigitalOcean, bare metal. I think Justin said he was tinkering with. So there are lots of different options for machine controllers that we'd like to build this year. I want to switch our Kubernetes, and in particular the kubeadmin tests, over to using the cluster API. So to test kubeadmin, right now we're using the Kubernetes Anywhere project, which is sort of under minimal support, purely for the purposes of making the kubeadmin tests work. So it'd be great to be able to switch those tests over to use the cluster API, since we want to have that be generally useful. That would also allow us to deprecate and stop supporting the kube-up code that's in the main Kubernetes repo. It's been on the list for quite a while to get that code out of the main repo, either by moving it out or deleting it. And so this will allow us to delete it, which would be great. And then lastly, he's got build something that actually uses the cluster API. So this is adding support for the cluster API into existing tools like Kops, KubeSpray, Kubicorn, Kraken. I think he doesn't mention it here, but I also think it's valuable if we put in our roadmap for the year to start building tools on top of the cluster API, right? So as I was mentioning in the conversation with Devin earlier, part of the advantage of having this common API is that we can build common tools on top of it that everybody who is using a cluster API compatible cluster can take advantage of. So things like node upgrades. Right now, pretty much every system builds their own version of node upgrades. And if we can have a common implementation of node upgrades, then that's one more piece of code that not everybody has to rewrite. Same thing with repairs, right? I think a lot of systems have not yet implemented things like automatically repairing the masters or automatically repairing the nodes when we notice that they break. And that's something we've had in GKE for a while, and it would be great to have in open source in a reusable fashion that everybody just sort of can get for free. So I think that's the other thing that should be on our roadmap that's not in the doc at the moment. Other suggestions, things that people want to see for 2018? Okay. Does anybody else have any more agenda items, or should we end a little bit early today? I think everybody's probably still recovering from the year turning over and getting back into the swing of things. I know I certainly am. It's going once, going twice. All right. Well, thank you everyone for coming today. Oh, Charles, go. Did you have something? Oh, all right.
No, I didn't.
Saying goodbye. All right, we'll see everybody next week. Have a great week. Thanks for coming.
See ya.
Cheers.